Consider the following linear programming problem where a school is preparing a trip for 400 students. They've reached out to a school bus company who's going to be providing the transportation for them, and this company has 10 buses of 50 seats and 8 buses of 40 seats. Let's perhaps call these buses S for small and L for large. And let's write down the respective numbers here. So 40 seats for a small bus, 50 seats for a large bus. We're also given some information about how many of each the company has, so let's write that down as well. We have 10 large buses and we have 8 of the smaller buses. Now notice here that the question says that the company only has 9 drivers available. So however we divvy up the buses for the school, it has to be the case that if we take the number of small buses and add to it the number of large buses, I won't be able to take more than 9 of them because we only have 9 drivers available. So that's our first constraint. Next up, let's try to develop a constraint over the number of seats that we need. So if there are 40 seats in a small bus and 50 seats in a large bus, we need to make sure that when we go to divvy up our students, we have enough seats for our 400 students. Now we can have more than 400 seats, but we need at least 400. So let's use a greater than or equal to inequality here. The last thing we have is information about the cost. So it costs us, let's say, $800 to rent a large bus and $600 to rent a small bus. This is going to give us information about what we're trying to minimize. We're trying to plan this trip for the smallest cost. So let's take P equal to 600 times S, $600 for a small bus, plus $800 times L, 800 for the large bus. All right, so we have our minimization equation. We have 2 of our constraints. The last thing we might want to do is just add a couple of extra constraints here on S and L. Since we only have 8 small buses, let's ensure that S lands somewhere in between 0 and 8. And similarly, we know that we only have 10 large buses, so we should make sure that L lands somewhere in between 0 and 10. All right, so let's formulate our axes and start working on getting our constraint lines actually plotted. Looking at S plus L is equal to 9, we know that if S is equal to 0, then we get L is equal to 9, and vice versa. If L is equal to 0, then S would be equal to 9. So that's going to give us a very quick way of being able to plot this line. We're just going to go up the L axis and put a dot here at 0, 9, and go across the S axis and put a dot here at 9, 0. Next up, let's take a look at the constraint line of 40S plus 50L is equal to 400. Let's start with S is equal to 0. If we were to divide both sides by 50, that's going to give us L is equal to 8. So let's go ahead and put that in green. And then coming back and considering L is equal to 0 and dividing both sides by 40, that gives us S is equal to 10. So I'm going to go ahead, I'm going to plot 10, 0 on the S axis. And we can go ahead and plot our 2 constraint lines. Now our last 2 constraints, I'm not super concerned about the one involving L because one of them has to say that L has to be less than 10. That's up here. That's not really going to affect our feasible region. However, the one where S has to be less than 8 could affect our feasible region. It depends on where this corner point is. So let's try to kind of determine where our feasible region is, get this corner point, and then we'll decide whether or not the S less than or equal to 8 is going to be an issue. For S plus L is less than or equal to 9, we're looking at the region underneath the black line. And for 40S plus 50L bigger than or equal to 400, we're looking at the region above the green line. So a little bit hard to see, so I'm going to zoom in and I'm going to highlight the feasible region. It's going to be this region in here. Okay, and that means that we have 3 corner points. We have one here at 0, 9, we have one here at 0, 8, and we have this third corner point here that we are going to need to determine. This should be at the intersection of S plus L equal to 9 and 40S plus 50L equal to 400. Here it's probably easiest to use substitution. Let's go ahead and solve for S in our first equation. It's going to be 9 minus L. And if S is 9 minus L, that means that 40 times 9 minus L plus 50L should be equal to 400. 40 times 9 is 360, minus 40L plus 50L should be 400. Now 50 take away 40, that's going to be 10L. And then 400 take away 360 is equal to 40. If we divide both sides by 10, we get that L is equal to 4. And if L is equal to 4, that means that S has to be 9 minus 4. S has to be 5. So our last corner point of interest is going to be 5, 4. All right, now we move into our minimization equation. We know that we're trying to minimize the cost, which is 600 for each small bus and 800 for each large bus. Let's take a look at 0, 9 and 0, 8. This implies that we either take 9 large buses or 8 large buses. Obviously, if we can fit all of the kids into 8 large buses, we don't need 9 of them. So that's not going to be the feasible solution. The cost for us, if we take 8 large buses, is going to be $6,400. Now the other possible option we have is 5, 4. This means 5 small buses and 4 large buses. Now this should fall within all of our constraints, so it's definitely possible to use this as a solution. Let's take 600 multiplied by 5 and 800 multiplied by 4. This gives a total cost of $6,200, and this is going to be our optimal solution. So in conclusion, we are going to rent 5 of the smaller buses. Each of those buses has our 40-seat capacity. And we're going to rent 4 large buses at the 50-seat capacity.